The first step in any migration journey is creating an accurate inventory of applications, dependencies, and data sources. Without a clear picture, hidden linkages can break when the database moves. Each system should be cataloged with details such as its data volume, update frequency, interface points, and downstream consumers. Dependencies often include batch jobs, reporting tools, or middleware layers that rely on specific database structures or stored procedures. A complete inventory helps estimate effort and select the best migration strategy. For instance, a legacy payroll application tightly coupled to a proprietary database will need a different plan than a modern web app using standard structured query language, or SQL. The inventory becomes both a map and a risk register, guiding decisions throughout the project. Assessment follows inventory by evaluating performance, availability, and compliance requirements. These criteria reveal what the future environment must deliver. Performance metrics like transaction latency and throughput set benchmarks to meet or exceed. Availability targets define acceptable downtime and recovery expectations. Compliance standards, such as data residency, encryption, or audit logging, ensure that migration does not violate regulations. For example, a financial institution must maintain strict audit trails before, during, and after migration. The assessment phase highlights gaps between current capabilities and desired outcomes, helping teams determine whether they need a lift-and-shift approach or deeper redesign. By grounding plans in measurable requirements, organizations minimize surprises later in execution. Migration strategies generally fall into three categories: rehost, replatform, and refactor. Rehosting, often called lift and shift, moves databases to a new environment with minimal change, fast but limited in benefit. Replatforming involves minor optimizations, such as adopting managed database services while keeping schema compatibility. Refactoring, the most complex, redesigns applications or data models to fully exploit cloud-native features. Each strategy trades effort for reward. For example, rehosting may yield quick cost savings, while refactoring unlocks scalability and automation. The key is alignment, matching the approach to business drivers, available time, and risk tolerance. A hybrid model may even apply different strategies to different workloads for maximum flexibility. Change data capture and synchronization maintain data consistency during migration. These techniques replicate changes from the source to the target in real time or near real time. This ensures that while users continue working on the old system, the new environment stays updated. When it's time to switch over, both databases are aligned, reducing downtime. For example, an e-commerce platform might use change data capture to keep order transactions synchronized until the final cutover. Implementation involves replication agents, transaction logs, or cloud-native streaming services. Continuous synchronization minimizes the risk of lost updates and supports stage migrations that roll out safely in phases rather than in a single disruptive event. Cutover planning defines when and how to complete the final transition. It considers maintenance windows, user impact, and rollback triggers. Detailed timing matters because even a few hours of downtime can disrupt operations. A strong cutover plan identifies who makes go or no-go decisions, how data validation will be confirmed, and what signals indicate success. Communication is critical. Stakeholders must know exactly when systems will be unavailable and when to resume normal operations. Some organizations use a blue-green approach, running both environments in parallel until confidence builds. Others prefer phased cutovers that migrate specific services gradually. Whatever the approach, clarity and rehearsed procedures turn a high-risk event into a managed, predictable shift. Post-migration tuning and indexing optimize the new environment for performance. Different engines handle queries, memory, and caching in distinct ways. Indexes that worked well in the old system may not be efficient in the new one. Query plans should be reviewed and statistics refreshed to ensure the optimizer makes smart decisions. For example, after moving from an on-premises database to a managed cloud service, workloads may run faster with fewer indexes because of improved parallelism. Performance tuning turns a successful migration into a high-performing system. Without it, organizations risk replacing old bottlenecks with new ones, undermining the entire effort. Updating connection strings and drivers is a deceptively simple but critical task. Every application, report, or integration that connects to the database must be reconfigured to point to the new endpoint. This includes credentials, ports, and sometimes security certificates. A missed configuration can cause silent failures or data inconsistencies. Automated deployment scripts and configuration management tools can reduce human error during this stage. Testing connectivity before resuming production avoids costly downtime. Even though updating connections seems like a technical footnote, it marks the moment when the business truly begins using the new database in daily operations, a symbolic and practical milestone in the migration. Observability and runbook adjustments come next to ensure smooth operations. Monitoring dashboards, alerts, and logs must reflect the new environment's metrics and naming conventions. Legacy alert thresholds may no longer apply if performance characteristics have changed. Runbooks, those detailed operational guides for handling incidents, should be updated with new commands, processes, and escalation paths. For instance, if backups now occur through a managed service, the recovery procedure must reflect that shift. Observability closes the feedback loop, allowing teams to detect issues quickly and maintain confidence that the new platform behaves as expected under real-world conditions. Rollback plans and contingency steps protect against unforeseen failures. Even with testing, migrations can uncover unexpected behavior once in production. A rollback plan defines how to return to the old system safely, including how to resynchronize data and communicate the reversal to stakeholders. This plan should be tested like any other part of the migration process, not written and forgotten. Contingencies may include maintaining dual rights temporarily or preserving snapshots at critical points. Knowing that a recovery path exists gives decision-makers confidence to proceed. Ironically, strong rollback plans often ensure they are never needed because teams proceed with greater discipline and preparation. After the dust settles, incremental modernization becomes the next focus. Once stability is confirmed, teams can begin adopting more advanced capabilities, such as automatic scaling, managed backups, or serverless query layers. Incremental modernization spreads change over time, reducing risk while still achieving long-term gains. For example, a company might migrate first, then refactor specific services to use microarchitecture patterns or introduce analytics capabilities later. The post-migration phase turns a one-time project into an evolving platform strategy, ensuring the database continues to improve as business demands grow. Migration success depends on steady, risk-managed transitions rather than speed alone. Each phase, from inventory to validation, builds trust in the system's continuity and performance. Modernization is not a single leap, but a series of deliberate, well-governed steps. By treating migration as both a technical and organizational journey, teams safeguard data integrity while gaining scalability and innovation potential. The result is a database environment that serves today's needs and adapts to tomorrow's opportunities, proving that careful planning and patience can turn even the most complex migrations into enduring modernization success stories. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.